Now see here particle nature of light. We have seen photoelectric effect, and you know the photoelectric effect actually establishes that the light is in the form of the small packets of energy, and these small quanta are the packets of energy known as photons. So actually here the interaction with the matter of the radiation actually according to the particle nature. It means the radiation behaves as a particle, and these particles are known as photon. So first thing is here, energy of the each photon is given by, if you take the first property, that is E is equal to h nu, where h is Planck's constant and nu is the frequency. Momentum of the photons is given by, that is P is equal to h by lambda, that is a Planck's constant upon the wavelength. And in this case, this is the second property we can take the momentum. And also the third important property we can take, we know that is Einstein's mass energy relation, mass and velocity relation, that is m is equal to m naught upon under root of 1 minus v square upon c square. So we can write m naught is equal to m into under root of 1 minus v square upon c square. Since in the vacuum or the free space, light travels with the speed of light, so we can write v is equal to c, so m naught is equal to 0. That means rest mass of photon is 0. So we can say actually photons do not exist at rest. And also here, if you increase the intensity here of this or the number of photons you made, that means if you increase the number of photons falling on the metal plate per second, their intensity increases, right, but in that case the energy remains same. So these are the certain properties of the photons. Photons are also chargeless and massless, not affected by electric field and magnetic field. When these photons enter from one medium to another, their speed changes. So all these properties you can do easily, and this property is very important for studying the particle nature of the light.